In this video, we discussed buoyancy. The central result is known as Archimedes Principle. It says that when a body is completely or partially immersed in a fluid, then the fluid exerts an upward force on the body equal to the weight of the fluid displaced by the body. And we can derive this from Newton's law. So let's do the derivation. So we consider an element of fluid, and this element is subject to its own weight, W fluid. And the rest of the fluid exert forces on this element. These forces are the forces of pressure, and they are perpendicular to the surface of the element of the fluid that we consider. And we can sum up all of these forces, and this is what we call the buoyancy force. And because of the element of fluid is in equilibrium, then the buoyancy force has to be upward, and it has to be equal to the weight of the fluid. And since the weight of the fluid element is rho fluid, V fluid times G, then the buoyancy force is rho fluid, V fluid times G. Now, if instead of the element of fluid, we have another object with the same shape, then the buoyancy forces will be the same. And so the buoyancy force is always equal to the weight of the fluid that is displaced by the body. Now, in this demo, I will try to measure the buoyancy force on a cylinder of aluminum. So I have a large beaker of water on a weighing scale, and the total weight is about 3.8 kilograms. And I attach a cylinder of aluminum to a Newton scale. Now it reads 10.5 Newton. Now I'm going to immerse the cylinder into water. And so the buoyancy force will push the cylinder upward, and so the reading on the Newton scale is decreasing. In the end, it decreased to 7 Newton. So the buoyancy force is 3.5 Newton. But if the water exerts buoyancy force on the cylinder of 3.5 Newton, then principle of action-reaction, it means that the cylinder exerts a force of 3.5 Newton to the water, which is then transmitted to the scale. And so 3.5 Newton is a little more than 0.3 kilogram. So the reading on the scale increased by a little more than 0.3 kilogram. So it was 3.8 kilogram. So now it is a little more than 4.1 kilogram. Now, since the buoyancy force does not depend on the density of the object, but it depends on the volume of fluid that it will displace, then this is why boats that are made of materials that are denser than water can float, right? They have a shape that is designed to displace a large enough volume of water so that the buoyancy force is large, right? You can even float a boat made of concrete. In fact, there is a national concrete canoe competition, and UC Davis usually has a team and participate in this competition. And in 2019, it is the University of Florida that won that competition. The buoyancy force, the buoyancy principle can be used to measure the density of a fluid also. How much an object is immersed will depend on the density of the fluid. And this is used, for example, to measure the density of acid batteries. The density increases as the battery is charged, and you can see it by reading how deep the weight scale sinks into the fluid.